All right, guys, so this is the video for section 12.3. And these are all about two-way tables. And two-way tables are pretty handy because they're pretty easy to read, especially after you get used to reading them. You should have done a chapter on two-way tables in Algebra 1, although I don't know if the middle school does that or not. So for those of you who took Algebra 1 through the middle school last year, this may be something you skipped. I don't know. Anyways, so let's go ahead and fill out this three-way table, or two-way table, sorry. So the totals are on the outside, and the inside is the numbers of more set groups. Okay, so here we're talking about gender and driving age. All right, so we're going to go ahead and fill the rest of these slots out. Okay, so if there's a total of 33 males and 28 started driving before or less than the age of 16, that means 5 had to start over the age of 16. So 28 plus 5 is 33. That's how I got that number. And we have 22 total females, and 8 started driving after 16, which means the rest of them, which would be, what is that, 14? Started driving before or at the age of 16. Okay, now if we go down, that means 13 total students started driving after 16, while 42 started driving before, and there was a total of 55 people. So notice 42 plus 13 is 55, 33 plus 12 is 55, and if you get this column and this column to add to the same thing, that's a pretty good indication that you did this correctly. All right, so let's go over some vocab. Okay, so a two-way table is just a frequency table that displays data collected from one sort that belongs to two different categories. So usually we're looking at two different variables here. Okay, so like the one we did here was age, or age you started driving, and gender. Okay. Joint frequency is each entry in a two-way table. And we'll do several examples of these. And it'll give you a better idea of what these are. Marginal frequency, or think of marginal in the margins, they're the sums of the columns and rows. And the joint relative frequency is the ratio of frequency that is not in the total row or the total column. Last but not, I guess we have two more. Marginal relative frequency is the sum of the joint relative frequency in a row or in a column. And then conditional relative frequency is the ratio of the joint relative frequency to the marginal relative frequency. Now, I know this is all just a bunch of words, and you're probably saying, what? We will go through, and one kind of stems off the other. It's kind of a building thing. Okay, so you'll understand it after we go through all these. All right, so let's look at example 2. Now, we're going to fill out this two-way table, and then we're going to answer some questions about it. Okay, so a two-way table displays the same information as a Venn diagram. Okay, so it does. It's just portrayed differently. In a two-way table, one category is represented by the rows and the other is by the columns. The Venn diagram shows the results of the survey in which 80 students were asked. Okay, that tells me we have a total of 80 students. I'm going to go ahead and put that right there. They were asked whether they play a musical instrument and whether they speak a foreign language. Use the Venn diagram to complete the two-way table, then use the two-way table to answer each question. All right. So if we look at this, we know the pinkish color is they play an instrument, and the blue is they speak a foreign language. Okay, so if I look right here, this 16 represents how many both play an instrument and speak a foreign language. So play an instrument and speak a foreign language, this would be my 16. Okay, Here they play an instrument, but they don't speak a foreign language. Okay, and here they speak a foreign language, but they don't play an instrument. And these 9 out here are in neither one of these bubbles, so they don't play an instrument and they don't speak a foreign language. Okay, so if I tally these up, this would be what, 46, this would be 34, those do add up to 80, so we're good there. Up and down, that's 41 total play an instrument, and 39 do not. That's pretty darn close, and those do add up to 80 as well. All right, so now that we have that, I want you to go ahead and try to do A, B, C, D, E on your own by using this, and then we'll go over the answers to those. All right, so A says how many students play an instrument? Play an instrument is here, so 41 play an instrument. How many speak a foreign language? When we're talking about speaking a foreign language, that's right here. The total that speak a foreign language is over here, and that is 46. How many students play an instrument and speak a foreign language? So we already talked about that. That's 16. These should be pretty easy, guys. How many students do not play an instrument and do not speak a foreign language? So no instrument, no foreign language. That'd be this 9 right here. And last but not least, how many students play an instrument and do not speak a foreign language? So they do play an instrument, they don't speak a foreign language. That would be 25. Hopefully that was pretty simple for you guys. All right, so let's look at example 3A. It says you randomly survey students about whether they are in favor of planting a community garden at school. 96 boys are surveyed, 61 are in favor. Of 88 girls, 17 are against. Organize the results in a two-way table. Okay, so the two things we have is we have boys and girls. And I'm going to go ahead and draw this. And we have boys and we have girls. And then we have in favor of planting the garden, and then we have not in favor of planting the garden, not in favor, okay, and then we have the totals on the outside. All right, so let's look at this. You randomly survey students about whether they are in favor of planting the community garden. Of 96 boys surveyed, so we know there's a total of 96 boys. Okay, 61 are in favor. Okay, so the rest would be not in favor, so that would be 35. Of 88 girls surveyed, 17 are against or not in favor, which means the rest, what is that, 71, are in favor. Okay. So if we add these up, there's 132 total in favor, and there is 52 not in favor. 132 plus 52 is 184. And if we did this right, 96 plus 88 is 184, which it is. Okay? So here's our two-way table. All right, so it says find and interpret the marginal frequencies. Okay, so the marginal frequencies, think of these as like the total columns. So we can interpret these two ways. So we can say out of 184 students, I can say 96 were boys and 88 were girls. Okay, so that'd be one side. Or I can say out of the 184 students surveyed, 132 were in favor of planting the garden, while 52 were not in favor. Okay, so either way, those would both be correct. All right, guys, so let's look at example 3. Now, I've just copied this table we did over here. so I don't have to keep flipping between screens because we will need this, okay? So now we're going to show a two-way table that shows the joint and marginal relative frequency based on the row total. So the joint ones would be in here, marginal ones would be out here, okay? So I'm going to use these numbers, but I'm going to present it as relative frequencies, okay? So relative frequencies, this is out of the entire number, okay? So I'm just going to redraw this, and you guys will have to do this on, I believe, both your quiz and your test, okay? So do know how to do them. All right, so here I'm just going to put boys, girls, in favor, not in favor, okay? And I'm going to go ahead and write each of these numbers down, except this end one. So 61, but I'm going to write them very small in the corner. 35, 17, 52, 96, and 88. Okay, so the joint and marginal relative frequencies is out of the entire total. So I'm going to put 61 out of 184, 71 out of 184, 132 out of 184. Okay, that's all I'm going to do. If I get the first one, I can do this one. Okay, and now that I did that, I'm going to go ahead and I'm going to find what that probability is. So I'm going to put 61 divided by 184 is 0.33. This is 0.19. If I add those, this is 0.52. Same thing here. I'm just plugging it into my calculator. 39, 0.09, 0.48. And think of this as a probability. Probability of all of them is 100%, so this plus this is 1. This is 0.72, 0.28. Those add to 1. When we add to 1, we're good. Okay, so this is joint and marginal relative frequencies. Okay, make sure you know the difference. All right, guys, so once again, I've just copied that original two-way table here, and I've gone ahead and set up here. Now we're going to make the conditional relative frequencies. So these are conditional upon one of the two things. So it's conditional upon being a boy or girl, or it's conditional upon being in favor or not in favor. So we're going to do this conditional on boys or girls. Okay, so these middle columns right here, the joint frequencies, I am going to keep those numbers. So, and I'm going to put it in the corner because we're going to do something with it. 35, 71, 17. Okay, and I'm looking more at boys or girls, okay? So when I'm talking about boys, remember there's a total of 96 boys, okay? So 61 out of 96 of the boys were in favor, 35 out of the 96 were not in favor, okay? And then girls, there were 88. So 71 out of the 88 girls were in favor, and 17 out of the 88 were not in favor. Okay, now if I plug these into my calculator, I can get 0.635, 0.81, 0.19, and 0.365. Okay, and if we go across, these add up to 1, and these add up to 1. Okay, I can do the same thing for in favor and not in favor. So go ahead and work through and do the same thing, but relative but conditional upon in favor or not in favor. All right, so this is what you should have gotten. These are conditional upon whether or not they were in favor or not in favor. So now we're going to put, our joint frequencies are the same, but we're going to put in favor out of 32, not in favor out of 52. Okay, so if I want to interpret these, I can say, notice these probabilities add up to 1, these probabilities add up to 1. So I can say of all the people that voted in favor, 46 were boys, 54 were girls. For all of them that voted not in favor, 67% were boys and 33 were girls. Okay, so two different approaches, but either one of these would work.